Hello friends, welcome to Physics Maestro. Today I have come up with a very amazing problem from Pathfinder problem book of physics from the chapter optics. So you can get this PDF from my Telegram channel. I'll give the channel link in the description. Let us move on to the problem. So it's the first problem from challenge your understanding segment. So let us read the problem. The problem says there is a cylindrical rod made of some unknown glass placed on a ruled white paper. If axis of rod makes an angle theta with ruled lines, the lines will appear broken and tilted at some angle alpha. In the figure, explain the appearance of the ruled line shown. Find the refractive index. So, let us now analyze the problem. So yes, uh, the problem wants to say that these are the uh, uh, ruled these are the lines of the ruled notebook, and this is the cylindrical lens. It is something like this. It's cylindrical. So yes, so this is a cylindrical lens. It is inclined at an angle theta on the ruled line. So the angle that the cylindrical lens is making on the ruled lines is angle theta, and the light rays, like, see, if we see, uh, this is the line. This should be the line. The line should move like this. Should move like this. But as you can see, there is some. But the line will appear. But the line is tilted in the cylindrical lens. So let us now uh, understand the ray formation in cylindrical lens. So we have understood that the cylindrical lens is inclined at angle theta on the ruled line, and the light rays that are coming out from the cylindrical lens, like first the light incident on the cylindrical lens and the emerging rays are at an angle alpha from the ruled lines. So yes, let us now analyze the uh, ray formation in cylindrical lens. Here you can see, whenever the light ray will fall on the cylindrical lens, there will be two types of formations. So the first one will be like this. So if you can see, uh, the cylindrical lens, the lines, this line is just parallel to this. You can see this. You can say these are dx or dl elements of the cylindrical lens. Basically, I want to just say that these lines will be parallel, and yes, and here you can see these lines will be perpendicular. So yes, lines, those will be parallel to their cylindrical lens, will just move on without deflection. This time it will act just like a glass slab, and here it will act like a spherical lens. As we have seen ray formation in spherical lens, and they emerge or diverge in lenses. So here also, in the first part, light rays parallel goes for a parallel light rays, it's just acting like a glass slab, and for the perpendicular light rays, it is acting like a spherical lens. Yes. So I have also mentioned this here, that rays being perpendicular to cylindrical lens converges just like a spherical lens. Converges just like a spherical lens. Rays being parallel to cylindrical lens axis behaves like being passed through glass slab. So yes. So the final uh, image, or the final ray formation of cylindrical lens will be like this. Uh, rays will fall. Rays rays will fall here, here, and a straight line. We will see. We will see a straight line. Yes. Now jump on to our analysis. So yes, here also I have mentioned these perpendicular these perpendicular this perpendicular rays will converge here. This will converge here, and we will see a straight line here. This will be the straight line. So let's analyze how the rays will uh, pass through the cylindrical lens. So we can see here, this is the axis, and let us say this is the thickness of the lens is dl. There will be some thickness, but we are just assuming that this is dl, or we can say that this is dl segment. So yes, if we see this and call it a dl segment, this will be the dl segment here, and this will be the theta angle inclination. I have also made this clearly here. This will be the theta angle inclination, and this will be the cos theta component, dl cos theta component, and this will be the sin theta component. Yes, this will be the dl sin theta component. So yes, so here you can see it is a very it's a very important part. Please watch it carefully. First, light rays will fall onto the cylindrical lens, will have a deflection of just angle theta, but when the light rays will emerge out of the cylindrical lens, we can see there will be a deflection of theta plus phi. You remember, theta is the inclination of the cylindrical lens on the ruled basis, and the alpha is the inclination of light rays from the ruled lines. So the net deflection, we can say, it will be theta plus phi. So yes, so for the first segment, or for the light rays parallel, there will be no magnification. There will be no magnification, but this dl sin theta component, since it's a spherical lens, there will be some sort of magnification, we can say. So for the spherical part, this spherical region, this bulging region, you can see this is the bulged region. For the spherical region, the light ray will be dl sin theta. We are calling it dl sin theta. So for the dl sin theta in the lens, it will be dl sin theta, and after coming out of the lens, it will become m times dl sin theta. M times dl sin theta. Dl sin theta will get magnified. Dl sin theta will get magnified passing through the spherical bulge. This is a spherical bulge. Dl sin theta will get magnified, and dl sin theta will be seen as m times dl sin theta. M is just the magnification. M is just the magnification here. And since for the parallel light rays, rays, there will be no such magnification. It will just act as a refractive part, just like a glass slab. So yes, so if we move on here, so yes, from here we can conclude dl cos theta being parallel will remain constant, and this dl sin theta will get magnified. Two conclusions we have made till now. So for the calculation, uh, from the general formula, mu to v by v minus of mu 1 by equals 0, uh, the magnification will come out to be m, and here mu 2 by v minus of mu 1 by u equals mu 2 minus mu 1 by r. And so yes, magnification will be mu 1 by u divided by mu 2 by v. This is for this segment cos theta part, and this calculation is for this part. Please remember this carefully. 2 and 1. So for the magnifications, we have wrote first divided by second. And first is this data, mu 1 minus of mu 1 by u, and the second is this data, mu 2 by v. Let us now move on further. yes, for the magnification formula, this is the outer region, and this is also the outer region, and this is the cylindrical lens lesion having some sort of refractive medium, uh, let's say mu. So yes, this will be for the bulged part of cylindrical lens, and its calculation will be like this. For air, it's mu equals 1, and also mu equals 1. So 1 by v minus of mu by minus of 2r. Since it is given the radius, the let's say it's r, so the net part will be 2r. So 2r. So yes, uh, yes. Here you can also see this here. This is the net bulged segment. This is the segment like this. This is the segment of the cylindrical lens. This is cylindrical lens bulge like this from here and below. This is the hole, and this part I have shown this here. So yes, mu of the this is the mu of the cylindrical rod or cylindrical lens, and if we if we see from the cylindrical lens, I have made this our eye. It's not natural, but yes. So yes, so if you see this from here, we will see this will be mu for the cylindrical lens, and with radius r. Light will fall like this, and will merge here. So yes, so for this we have seen from the previous result, magnification is first part by second part. Here this is the first part and this is the second part. So yes, first by second we will get the value of m equals mu by 2 minus mu. So yes, let us now move on further calculations. So you can see here we are almost on the ending of our solution. So yes, uh, as you can see here, this was our cylindrical lens. This was our cylindrical lens. Remember, uh, these are these were the ruled lines. These were the ruled lines, and these were the deflections. So yeah. So yes, let us now move on further. This was this was this is the outer segment of the cylindrical lens placed on the ruled part. This was the ruled part, and so yes, so this is the net deflection. Remember, I said the light rays will fall here and will get a net deflection here. Will get a net deflection like this. Rod was inclined at angle theta, but the light rays coming out of the cylindrical lens was at an inclination of angle alpha from the ruled lines. So yes, the net deflection we can say for a perpendicular, let's say this is the perpendicular uh, cylindrical lens, so we can say the net deflection will be along this will be like dl cos theta for this segment, for this part, as we had said. These, let's say this is the dl length, this is the dl length. Yes, so it's my first video, so I'm getting some confusions in using this. So yes, this was our dl, and we had said so yes, this was our dl, and we had said for the theta this will be dl cos theta, and this will be dl sin theta. And we had said that this dl sin theta component, emerging like this dl sin theta component will get magnified, and this is the magnified value of this dl sine theta. Dl cos theta will remain as it is, glass slab. There is no magnification from the glass slab. So yes, it is dl cos theta. It is m times dl sine theta from the spherical region. So uh, for the further calculations, we can see tan of theta plus phi, this theta plus phi, this tan of theta plus phi, m times dl sine theta comp m times dl sine theta by dl cos theta. So these are vectors. So like we can say that this m times dl sine theta is here, and this is dl cos theta. So perpendicular by p by b. So yes, yeah, this perpendicular by this. So m times dl sine theta by dl cos theta. This will be m times tan theta, and we had calculated the value of m here, m times m equals u by 2 minus mu. So yes, this is the calculations, and here this is the calculations, and if we now just cross multiply like this, tan of theta plus phi, tan of theta, and we just do just little calculations, we will get this value. And here if you like component into dividend, uh, like this is very basic, but yes, so if we apply here component and dividend, we will get the value of mu. So I hope you like this video. uh, Please like and share, and you can get these videos for free. As I have already mentioned, I will try to give the Telegram channel link in my description. If you want more videos, you can comment. I will try to make more such videos, and I generally try to solve or post solutions of a problem for more than 3 approaches or at least 2 methods. So yes, I will try. If I find some another method of this, I will try to post it. But yes, I will try my best to include such problems with multiple methods and multiple approaches. So thank you, take care, bye bye.